Right, so with this question here, you've got this mass of 75 kilograms. Okay, it's on a rough plane, inclined at 25 degrees. Okay, and we've got the coefficient of friction is 0.3. Now it says there's a force of magnitude T newtons, which is acting on the object in the direction parallel to the line of greatest slope. It's not clear which direction this force is, T newtons, whether it's acting to pull it up the plane or down the plane. But then when you read A, right, I think it becomes clear, because it says, given that the object is just prevented from sliding down the plane, okay, which means it's on the point of slipping down the plane, okay. It's on the point of slipping down the plane, of course, because you've got the weight component here, okay, of the object, obviously wanting it to go down the plane, right? As the natural instinct is for it to roll down, okay. Of course, that weight component there would be 75g, maybe sine 25 on it, okay. Now, if it wants to go down, of course, there will be a frictional force then opposing it on a rough surface, okay. The frictional force will be acting up the hill, but by the looks of this question, it would still fall, right? It would still fall, but there's this force of magnitude T acting along this line to just keep it just about in place. So we've got something here, sort of pulling it up, whether it's a rope or something. Okay, it's just preventing it from slipping. So as well as the friction opposing it falling down the slope, you've also got some sort of tension here. Okay, so then we can see resolving this weight in this component as well. So it'll be 75g cos 25. All right. So we can now apply Newton's second law. Okay. In the direction of motion, okay. Obviously it's not moving, but we can think about the direction it would move in. Okay, and it's about to fall down the plane, isn't it? Okay, so that would be, in other words, that would be parallel to the plane. Okay, so we've got 75g sine 25. Take away then the friction, which is opposing it, and also take away then this T force, okay, which we asked to sort of work out. That will equal then to the mass times acceleration, so 75 times A, but of course it's just been prevented from sliding down, so A is going to be 0, isn't it? So we'll have 75g sine 25 minus friction minus T will equal 0, okay. Now we can also resolve perpendicular to the plane, okay. So again, apply Newton's second law, or just think about then appreciating that there's no acceleration perpendicular to the plane. Okay, the object isn't jumping up and down here, right? It's staying attached to that plane. So the R will equal the 75g cos 25. Okay, so that will sort of balance out with the force opposing it there. Now, as it's on the point of sliding down, right, because it does say just, doesn't it, there, okay, so we can say, look, as it's on the point of sliding down, we can say that the friction will equal mu r, okay, friction is going to be at its max, because it is literally on the point, and it's only been prevented by this tension force, okay. This T force has been applied. So we know that mu is 0.3, stated in the question, and of course we know R is that. Okay, so we could work these things out, but perhaps I'll just leave it there for a minute before I go about it. Now what's good then is, because we had this equation 1 here, yeah, and we had this equation 2 here, and we've used equation 2 to work out the friction, knowing mu is given to us. So now, with the friction here, we can sub that into equation 1, okay? So we can say, look, sub into 1. So it's always useful to resolve parallel and perpendicular, because the equations then will sort themselves out. So we've got the friction, sub it in here, so we've got 75g sine 25. Take away then this, which is 0.3 75g cos 25. Take away the t, and that equals 0. So from all that then you can work out what t is. So we can take that minus t over, so we get t equals to basically all of this. Okay, I take the minus t over, so you get 75 times 9.8 times sine 25. Take away then 0.3 bracket 75 times 9.8 times cos 25. So let's work that out. One long calculation on my calculator. And I've got that to be 110.78 newtons. Okay, so the value of t there. So we've got that in place for part A. In part B, it says given that t equals 0, find the magnitude of acceleration of the object. So if you think about it, right, we needed this 110 newtons in place to pulling this up so that it balanced and there's no movement. But if you suddenly take that force away, well then it's going to slide on the plane, right? Doesn't matter about friction, it's still going to go down, but we're going to have an acceleration. So if we again apply Newton's second law, okay, to this, we'll have 75g sine 25, okay, taking us down the plane. Of course, then opposing us will just be the friction, okay, which we'll call f off in a minute. I'll sub in the value I had earlier, and that will equal to then the mass times acceleration. Okay, so it's just a case then of substituting in. So you notice now there's no t because that's taken away from us. Friction, which if I checked earlier I had 0.3, that's how I got it, 0.3 times 75g cos 25, and that will equal then 75, which is the mass times the acceleration. So again then, it's a case of working all that out on my calculator. So 75 times 9.8 times sine 25, take away 0.3 bracket 75 times 9.8 times cos 25, and then of course that will equal then to 110.78. Divide that then by 75 and I get A to be 1.48 newtons, sorry, not newtons, meters per second squared to 2 decimal places.